Imagine a place surrounded by trillions of icy rocks with a mystical dwarf star. A ball of magnetic bubbles, each 100 million miles across, ravaged by a cosmic war between fields of deadly radiation. This isn't a distant part of the galaxy. This is our own backyard, our solar system. And what's going on in its outer reaches determines whether we live or die. Over the last century, our understanding of the universe has exploded. We've discovered billions of stars in our galaxy and billions of new galaxies across the universe. We've seen black holes shooting out cosmic jets, exploding Death Stars, and new planets in distant solar systems. But when it comes to our own cosmic zip code, we know remarkably little.
When we study space, the closest thing to us is our solar system. So that's what we should understand the best. But it turns out we're just getting started. We don't understand everything in our solar system.
The solar system is our home, our local neighborhood. But it may surprise you to know that we don't really understand how far it extends.
When I was a kid, I was taught that where the planets were was the solar system, so that the farthest planet at the time, Pluto, was where the solar system stopped. And it turns out that's completely wrong. If you think that the solar system stops where the planets stop, where Neptune and Pluto are, you're missing the big picture, literally.
We're just coming to grips with a stunning fact. Over 90% of our solar system begins where the planets end. By the time the sun's light reaches out that far, it's desperately weak. But we knew something was out there because it kept sending us visitors, comets. It was proposed that they came from a mysterious disk out beyond the orbit of Neptune, but no one thought it would be proven.
The Kuiper Belt was theoretical. It was thought to exist, but it was also thought that it would be too hard to observe. You're talking about objects which may be 100 miles across, but they're billions of miles away. Trying to find something that's much, much smaller would be incredibly difficult, and no one really thought you could do it.
In 1986, a team of astronomers based at Hawaii's Mauna Kea Observatory decided to prove them wrong.
I'm a bit of a hoarder. These are the notes that we took while we were observing. I used to write lots of things in a notebook to try to keep track of everything that was happening on the mountaintop. Here's the name of the telescope, the 88-inch telescope on Mauna Kea, also known as the Rust Bucket. Visitors to that telescope always think it's the ugliest thing they've ever seen. It's painted brown, it looks like it's totally rusty, parts of it are rusty. So it's a horrible looking telescope, but we use it for all of our work.
If they could locate an object beyond the planets, it would have to inhabit the ghostly Kuiper Belt. For 6 years, they found nothing. It was like trying to find a rusty dime in the state of Texas.
We spent many, many years looking for objects in the outer solar system. Lots of pain, frankly, lots of disappointment.
You have to really have some respect for the scale of objects. Yes, we can see stars that are hundreds or thousands of light years away, but they're these giant glowing objects. How do you see something that's only 100 miles across and it's dark, it's not giving off any visible light of its own? That's why finding these things have been difficult.
Kuiper Belt objects are made of mostly ice. So you'd think they'd sparkle like icebergs.
We're in a volcanic country, so some of these icebergs are actually dark, covered in ash.
And they're a perfect analogy for a Kuiper Belt object.
So I really wanted to get close to this one, but my guides just told me that this one's too big. We can't get close, it might flip over. All right, we found a really cool one. It's really dark. Let's get over here. So, you see how black this thing is on the outside? Well, comets are also black, but actually, they're even blacker than this. We think that comets typically are blacker than asphalt, blacker than tar.
Comets are black because they've been barbecued by the sun.
So where does this black come from? It's not ash. Well, we now know that comets have a lot of organic molecules. That means molecules with carbon. And when these things get blasted by ultraviolet radiation and cosmic rays, they kind of get charred and turn black. So it's a lot like you had a piece of meat and you leave it on the barbecue too long and it gets charred black. It's the same thing going on with comets.
The Kuiper Belt objects are the same. They are small, blending into the dark background of space.
The problem with studying these objects is that they're just very difficult to see. It requires a very large telescope to do so.
The ink-black Kuiper Belt objects stayed hidden for half a decade. Then, one summer night, Jewett and his team spotted something, and the solar system would never be the same.
So here's the log sheet, the notes that we keep while we're observing. 29th of August, 1992. We started as normal, looking at the images as they came out of the telescope, and found this first object.
It was a single, tiny dot, moving very slowly across the sky, and its slow path showed it was orbiting the sun, but in an orbit that took it way beyond the planets, an orbit that would put it in the mysterious Kuiper Belt.
It was moving incredibly slowly across the sky, and therefore was incredibly far away. And we knew, just from the slow speed, we knew immediately it was the most distant object ever seen in the solar system up to that point. Here's this note, SMO, slow-moving object, question mark. So that's the discovery of the Kuiper Belt right there, with those three tiny little letters.
In an instant, the Kuiper Belt became real, and our solar system became twice as large.
It was groundbreaking because now we have this whole part of the solar system that we had predicted but had no evidence for. Boom, evidence. The discovery of the first Kuiper Belt object was a clear indication that there is this new population of objects out there. Basically, overnight, we doubled the diameter of the solar system.